Hi, welcome back to Math 533, Topics in Euclidean Geometry. In this video, we're going to look at the converse to the Pythagorean theorem. And a really nice feature about the converse to the Pythagorean theorem is it allows us to construct right triangles even if we don't have a t-square or something like that capable of making a right angle for us. Right? The basic idea is for the converse to the Pythagorean theorem, you use an algebraic fact like 9 plus 16 equals 25. We use this algebraic fact to build a right triangle. Okay, let's go ahead and prove this thing. So let's start with the statement. Suppose I have a triangle and I don't know anything about the angles. I just know something about the side lengths. So I suppose that ABC is a triangle so that, right, with the sides labeled the way we did before, a squared plus b squared equals c squared. Then if we know this about the lengths of the sides, then that forces my triangle ABC to be a right triangle with its right angle in C. And so this is a backwards implication from the Pythagorean theorem that we proved in the previous video. So let's go ahead and prove this converse to the Pythagorean theorem. And the idea of the proof is basically what we've been doing many times before. What we do is we take the information we have, and I want to construct a triangle ABC, and I want to make it so that A prime C prime is congruent to AC, B prime C prime is congruent to BC, and the angle in C prime is a right angle. Right? So this is a little schematic over here representing my new triangle, A prime, B prime, C prime. Right? So I have the side length A from my old triangle here, side length B from my old triangle here. I have a right angle in C prime by construction, and I have this unknown length of the hypotenuse C prime. Okay, so by construction, as I said, A prime C prime is equal to B, B prime C prime is equal to A. But now what we do is in our right triangle here, A prime, B prime, C prime, we apply the Pythagorean theorem. And that tells me that A squared plus B squared equals C prime squared. And now we use the hypothesis. A squared plus B squared equals C squared. So I have C prime squared is equal to C squared. And of course, distances are positive, so I can take square roots of these two numbers, and I have that C equals C prime. So now by side, 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 triangle ABC is congruent to triangle A prime, B prime, C prime, right? Because we just proved that this quantity here, C prime, is equal to C. So now we have the side, side, side condition. And from that congruence of those two triangles, the angle in C is congruent to the angle in C prime, and lo and behold, the angle in C prime was a right angle by construction, and hence the angle in C is right. This is a surprisingly useful theorem. Let's take, I'm going to make a little, imagine this thing where I take a length of rope and I will take it slightly longer than 12, let's say 12 feet long, and I tie knots in them at 3 feet, then at 7 feet, and then I tie the ends together to get a loop that's 12 feet long. So then I have a loop of string with knots, let's say at some point here, another point here that's 3 feet away, another point there that's 4 feet away, and then 5 feet away. And if I pull this taut and I hold on to the knots, I'm going to be able to get a right angle there by the converse to the Pythagorean theorem, right? So that right there gives me a right angle. This construction is still used today. So on this website, you see there are instructions for using 3, 4, 5 right triangles in order to square roofing. Take a look on Blackboard. I have a link to this video, and I will put it also down in the description box below. Okay, that's it for this video. Thank you for watching. I hope you enjoyed it, and I hope you liked this sort of what I think is a fun recurring idea in this geometry class, that sometimes when you want to prove something, you construct an object with the properties and you show it has to be the same as the object you started with. Right? So we did this for the angle side angle theorem. We did it with the converse to the alternate interior angles theorem. And here we're doing it for the converse to the Pythagorean theorem. It's a useful trick. Keep that in your toolbox in the future. Thanks for watching. I hope you enjoyed this. Happy mathing.